Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The second reactant is beta-dimethylacrylic acid, 3-methyl-but-2-enoic acid, CH3, to C is equal to CH2. This is an alpha-beta-unsaturated carboxylic acid. Moving on to the next step. UlCl3 is a Lewis acid catalyst used in Friedel-Crafts reactions. With an unsaturated carboxylic acid, UlCl3 can coordinate with the carbonyl oxygen and promote formation of an acylium type or carbocation intermediate. Moving on to the next step. UlCl3 complexes with the carboxylic acid. The protonation activation of the double bond or the carboxyl group generates a tertiary carbocation at the beta carbon, the CH3 to C plus end, because the dimethyl substituted carbon forms the more stable tertiary carbocation. This is a classical Friedel-Crafts alkylation via a carbocation intermediate rather than acylation. And for the final step, CH3 to C is equal to CH2 plus UlCl3, CH3 to C plus CH2 tertiary carbocation at the isobutynyl terminus via protonation of the double bond or via ionization. The tertiary carbocation CH3 to C plus attacks benzene in electrophilic aromatic substitution. The tertiary carbocation CH3 to C plus CH2 attacks the benzene ring, giving PHC CH3 to CH2 after loss of proton. This is 3-methyl-3-phenylbutanoic acid, which corresponds to option C, a benzene ring bearing a C CH3 to CH2 CO2H group. Option A would require a different carbon skeleton with isopropyl and CO on the same carbon attached to phenyl, does not match the expected carbocation pathway. Option B would be the Friedel-Crafts acylation product, a ketone. Acylation would give PHCOCH is equal to C CH3 2, but the high yield 82% and the known chemistry of beta-dimethylacrylic acid with UlCl3 favor alkylation via the tertiary carbocation, not acylation. Option D is tert-butylbenzene, which would require loss of CO2 as well. While decarboxylthione can occur, the observed 82% yield product retains the carboxylic acid function as in option C. The reaction proceeds via Friedel-Crafts alkylation where UlCl3 promotes protonation across the double bond to give the tertiary carbocation CH3 to C plus CH2 which then alkylates benzene to give PHC CH3 to CH2 option C. Therefore, the correct answer is C. Therefore, the correct answer is option C.